Hey bloggers, welcome to my house, Homeschooling with Miss Castro. Starting today is our first lesson, which is correcting your integrals review quiz. So let's get started. All right, so the first problem, there it is. I mentioned before we started the quiz that both problems would require substitution, and so I was kind of surprised how many of you decided not to use substitution. So really you need to use substitution on these. So the first hint is find the part of the function that has the highest exponent. So that would be right here, x to the fourth plus 1, and make that your u. Because when you take the derivative of your u function, you should end up getting something like this right here. So du dx, the derivative of u, is going to be 4x cubed. Aha, there it is. So I tried to make the first problem as simple as possible. Okay, my dogs are driving me nuts. This is the second time I've started this video because they keep barking, so we're just going to keep going. All right, so this is my du dx. This is my u. So I can rewrite it, du dx, and times the square root of u dx. Now, because I have the du dx, I can cancel out the dx's. Dx divided by dx cancels out. So I'm left with the square root of u du. All right, if you look at your formula packet, we do not have a formula for the square root function. Instead, what we do is we rewrite it in exponential form. So that would be u to the 1/2. And now we do have a formula for finding the integral of u to the 1/2. Because whenever we have an exponent on a variable, all we have to do is add 1 to that 1/2. and then multiply by the reciprocal of the new exponent. So 1/2 plus 1, that's the same as 1 is the same as 2 over 2, so that's going to be 3 over 2. So when I integrate this, I'm going to get u to the 3/2, and then I need to multiply by the reciprocal of that new exponent, so I'm going to multiply by 2/3. Okay, so that is the, there it is integrated. Since it's an indefinite integral, we need to write plus c. Okay, now I can substitute back in for my u. So I get 2/3. My u was x to the 4th plus 1. Sorry, can you see that? X to the 4th plus 1. And that's raised to the 3/2. Now, the reason why most people lost a point on this problem is the directions said to write the answer in radical form. A radical is a square root. Okay, so a bunch of you didn't have that. You just left it in exponential form. So to change this to radical form, that means the denominator here is going to be our radical. So the parentheses are going to end up back underneath the square root. So it will be 2/3 times the square root of x to the 4th plus 1. And that's raised to the 3rd. And it doesn't matter where you put it. You can put it on the inside or you can put it on the outside. So if you had it like that, that would be fine. You also could have put it outside the radical. I would have been okay with that. So that or 2/3 radical x to the 4th plus 1 to the 3rd plus c. Either one of these is fine. But do be careful about the directions that you're reading, what form your answer should be in. All right, problem number 2 was a little bit trickier. So it was sine of 4x and y equals sine of 4x, and you were asked to find the area under the curve, and you were given this picture, and do I have the picture handy? There, yeah. So on the picture, I actually gave you some values here, pi over 6 and pi over 3. And some of you were really clever. You noticed that this was crossing the x-axis halfway in between pi over 6 and pi over 3. And so you figured out what is halfway in between pi over 6 and pi over 3. I thought that was very clever. Some of you actually wrote, you did your unit circle, and you said, okay, here's pi over 6, and here's pi over 3. And you said, what's halfway in between this? And you went, oh, 45 degrees, or pi over 4 is halfway in between. So some of you just reasoned out what this intersection was going to be. And on the test, I did mention the graph is drawn to scale. So you could use the graph. That was fine. You could do this and figure out what's halfway in between that. Some of you used the unit circle to do it. Others did this. You found a common denominator for these. So pi over 6, you could change that to, oh, actually, anyway, yeah. Some of you changed it to pi over 12, and this one, oh, sorry, 2 pi over 12, and this one to 4 pi over 12. And then you said, okay, what's halfway between 2 pi and 4 pi? That would be 3 pi. So 3 pi over 12, oops, I'm going off the edge here, 3 pi over 12, which reduces to 1/4 pi, or pi over 4. Okay, so I saw it done a bunch of ways. The most common way, though, is that people realized that sine of 4x had to equal 0. So that means we needed to figure out what angles have a sine of equal to 0. So sine is the y value. So where is the y value 0? So back to our unit circle here. Right here we have 1, 0. That's one answer. Sine of 0 is equal to 0. So that means this angle right here, 4x, could be equal to 0, because if 4x equals 0, the sine of 0 is 0. Okay, right there. But that would be that one. Okay, that would be that intersection. Well, what about the next one? Where's the next place on my unit circle that sine of theta equals 0? Well, that would be over here. This is the next place at -1, 0. That's the next place on our sine function where sine of theta is equal to 0 right here. So that is pi. So I know that 4x needs to be equal to pi. So sine of pi is equal to 0. Now I got to solve for x, divide both sides by 4, and you get pi over 4. Okay, so there's 3 different ways to get that other intersection, because we're trying to find the area under this curve. So once you have that, whether you use the unit circle or you figured out what's halfway between pi over 6 and pi over 3, oh, I just thought of another way. You could find the average. What's halfway between two numbers? The mean. You do pi over 6 plus pi over 3 divided by 2. Okay, and this is why teachers don't teach from home. Now my phone is barking. This is making me crazy. Okay, and it's my kid. You'll have to wait. All right. So anyway, you could finish that up and you would get pi over 4 also. Okay, so the next thing is we need to integrate this sine of 4x from 0 to pi over 4. Pi over 4. Okay, I feel like I need a little more space on here, and I'm not going to get it. Oh, let's see if I raise this up. There we go. All right. So now remember I said there's going to be a function inside of a function. We're going to be using the chain rule. Here it comes. U is equal to 4x. So du dx is equal to 4. The derivative of 4x is 4. Do we see a 4 in here? No. So this time we have to put it in. So we need that 4 to be in there. So from 0 to pi over 4. But if I put that in, I got to counterbalance it. Okay, I can't just times by 4 and have everything be right with the world. I got to also multiply by 1 over 4, because 1/4 times 4 is just 1. I am allowed to multiply by 1. Oops, I forgot to put my dx. Now I have my du dx is here, and my u is going to go here. So I now have 1/4 from 0 to pi over 4 of 4 is my du dx, times the sine of u dx. Now I can reduce my dx's, and I'm left with 1/4, 0 to pi over 4 of sine u du. Now I'm ready to do my integral. So when I integrate sine of u, I get negative cosine. So a bunch of you gave me positive cosine. I don't know if you were taking the derivative or if you just forgot to put the negative sign. And these are in the formula packet. When you integrate sine of x, it tells you it's negative cosine x. So no excuses on that. All right, and then this is going to be multiplied by 1/4, and it's going to be evaluated from 0 to pi over 4. All right, so now we're ready to do our substitution, and there goes my silly dog barking away. So I'm going to bring it up here. Do my substitution. So I'm going to have 1/4. I'm going to multiply by 1/4 all at the very end. So I'm going to have negative cosine of, oh, I almost forgot. I need to put back the 4x. Sorry. Negative cosine of 4x from 0 to pi over 4. Okay. All right, so negative cosine of 4 times the upper boundary, pi over 4. And that's going to be minus negative cosine of 4 times 0. Gosh, do I have enough? Do I have the right number of parentheses there? Okay, so 4 times pi over 4, the 4's cancel out, so I just need cosine of pi. Well, back to my unit circle up here, cosine is the x value, so that would be negative 1. So here I have negative cosine of pi is negative 1. So notice I'm going to have minus a negative there. Still have my 1/4. And then minus negative, and then what's cosine of 0? 0. Well, that would be 1. Oh, look what's happening. So I have minus a negative is a positive, minus a negative is a positive. 1 plus 1, and then times 1/4. It's getting windy out there. 1 plus 1 is 2. So then I have 1/4 times 2, which is equal to 2 over 4, which is equal to 1/2. And I didn't call you out on this if you didn't do it, but it would be units squared. Okay, it is a positive area. So for those of you who got negative areas, that should have been a warning sign for you to look at what you were doing, because clearly this area is all above the x-axis. All right, so there it is. Good luck on your corrections, and if we ever get back to school this year, we will have an opportunity to retake this. All right, bye-bye.